Alright, I'm going to do an example here of finding the angle between two vectors given in component form. It says find the angles between the vector -5, 2 and -9, -8. Carry your intermediate computations to at least 4 decimal places and round your final answer to the nearest degree. Make sure your calculator is in degree mode. If you're using the Alex calculator, make sure it's in degree mode. If you're using your regular calculator here, again, to switch the modes, you have to hit this button here where it says mode, hit it twice, mode, and then number 1 is degree, because you may have it in radian mode from doing other problems. So make sure your calculator's in degree mode. So I'm going to go over here to my scratch paper. And first of all, what we need to do in order to find the angle between the two vectors is we are going to use a cosine. And the cosine of theta is going to be equal to the dot product of A and B divided by the magnitude of A times the magnitude of B. And so in order to find my dot product, A dot B, I have to use my formula. If I have my two vectors, A1 and A2, and then B1 and B2, what you're going to do is take A1 times B1 plus A2 times B2. And then in order to find the magnitude of my vectors, my formula for the magnitude of a vector is that I have the square root of x squared plus y squared. So on this problem here, we have the vector -5, +2, and the vector -9, -8. And so if I'm going to do my dot product, I'm going to take -5 times -9, the A1 times the B1, -5 times -9. I'm going to add A2 times B2, so 2 times -8. So that would give me 45 plus -16. 45 plus -16, 45 minus 16 would be 29. If I get all my work shown there. If I go ahead and do the magnitudes of each of my vectors, so I'm going to have the square root of x squared plus y squared. And so here I'm going to have -5 squared plus 2 squared. And on the other one, I'm going to have -9 squared plus -8 squared. So here, 25 plus 4 gives me the square root of 29. On the other one, I would have 81 plus 64, which gives me the square root of 145. So when I do this, I am going to do the arc cosine or the inverse cosine. So on my calculator, it's the cosine to the -1 of my dot product, which was 29, divided by the square root of 29 times the square root of 145. And that's what I'm going to use on my calculator. So a little harder to do on your handheld calculator because you have to make sure you put those two square roots together. So if I'm going to do that, again, make sure you're in degree mode. You should see a little D up there. So inverse cosine of, maybe I have to do parentheses, 29 divided by parentheses square root of 29 times square root of 145. Close my parenthesis, close my parenthesis. There we go. I get 63.43. So notice when I put that in on my calculator, I had to put the parenthesis in front of my 29. And then if I cursor over here, I also have parentheses around the square root of 29 times the square root of 145. So I had to close my parentheses twice, once for around the square root, which was the denominator of a fraction, and once around the whole expression. So to get it to work on this calculator, you need the parentheses around the entire value as well as around the denominator. It's probably a little bit easier to use the Alex graphing calculator. If I hop over to the Alex graphing calculator, again, make sure you have it in degrees. That if it's not in degrees and it's in radians, click that button. It toggles back and forth between radians and degree over there on the right hand side. So I got to make sure it's in degree mode, which it is now. Then I'm going to do the cosine of, they already put the parentheses around the whole thing, so I can put my 29 divided by, and then I'm going to have the square root of 29. And then you have to make sure you get out of that square root. So if you arrow over one space or click over there, but hitting the arrow to the right works pretty good. And then I'm going to have the square root of 145. And so it looks like that when I enter it into my calculator and I hit equal. There's my 63.43, which again I'm going to round off to 63 when I do that one.